let's practice tracing through a recursive algorithm. And the algorithm that we are going to use here is developed for generating the sequence A of n equal A of n minus 1 plus 2, with the first term A1 equal to 4. Now, when you're tracing an algorithm, there's no right or wrong way of recording information as you walk through the algorithm so that you produce the accurate output or result. So feel free to take as many notes as you like as you're tracing through the algorithm, and that way you'll ensure that you produce the accurate output. So as we look through this sequence algorithm, the input is some number n, and then we have an immediate conditional operation, an if-then operation. And after that is completed, we output an array form output, so a list or set of elements of that sequence generated by the algorithm. So let's practice this for an input of n equal 5. So what I'm going to write down here first is just an abbreviation of our function name sequence S, and the fact that we are inputting the value 5 first. So let's look through and see how that's going to work as we trace through this if-then statement. N is not equal to 1. So we're going to drop down to the else statement and execute it instead. And that would read A of 5 equals so forth. So let's write that down. A of 5. And what does it equal? Well, notice we're calling upon the sequence function again with the value n minus 1. So let's write that down. A of 5 is going to equal n minus 1 would be 4 here, since n equals 5. So S of 4 plus 2. So we've got some good notes going here. Just reviewing what we have done so far, I would say it might help me to also say, okay, here is where n was 5. So now we need to evaluate S of 4. In other words, what is sequence when n equals 4? So I'm going to dedicate my next box here in my trace map for what happens when n equals 4, executing S of 4. And looking at our if statement again, n is not equal to 1, so we execute the else component. A of 4 is going to equal S of 4 minus 1, so S of 3 plus 2. And so in order to determine what A of 4 is, we need to know S of 3. So we'll move on and evaluate for when n equals 3, S of 3, what does it produce? N is still not equal to 1, so we execute the else statement. A of 3 equal S of 2 plus 2, because the S part has an input of n minus 1 here, so 3 minus 1 for 2, and notice we need to execute S of 2 now. So the pattern is becoming repetitive here. It's becoming more second nature as we practice tracing through here. And so I'm just going to quickly show, okay, n is still not equal to 1, so A of 2 equal S of 1 plus 2. And we're going to evaluate for n equal 1, S of 1. And oh, now we are at that point where n equal 1. So we execute the statement as it shows in the if line. A of 1 equal 4. All right, so let's write that down. A of 1 equal 4. And so now that we have produced S1 with an output of 4, we can sub it back in to our recursive components here in the previous cycles through or traces through the algorithm, you can think of it as. And I'm just going to come down here and complete our A equal 2 line now. 4 plus 2 for 6. A of 2 equals 6. And then we're going to come back into our previous iteration and use 6. And that gives us 8 for A of 3. Come back into the previous cycle and use that output of 8 for 8 plus 2 or 10. And finally, in that very first cycle through the algorithm, we had 4, or when equal 4, we got an output of 10. We'll substitute that in. Plus 2 gives us 12. And so now as we think about what the final output would look like, it's an array form, so a list or a set of items in their order as it would naturally be sequenced. And so we would say A of n equals a list of items, and different programs may output this differently. I am just going to show with some spaces between our elements. So we got 4 for our first term, then 6, 8, 10, and then 12. And like I said, different programs like MATLAB or R or whatever computing software you're working in, could be C++, might output that a little differently. They might have, say, some braces around it, commas in between, you name it. But you get the general idea of how to trace through this recursive algorithm.